And we're live. So, don't have anything new today. However, the problems for the homework this time around, which will be due on, this will be Tuesday for everybody, will include some disk method problems that we call washer problems. These are problems that don't have the radius set at the x-axis, which means you will have an R1 and an R2 this time around instead of just an R1 like you had for the homework this time around. So because the math isn't any different, I'm going to start by calling on people right away, I think. So what we're looking for is same thing as last time. We're going to create a volume in 3D that results when we spin this two-dimensional area that we have here in blue about this axis of rotation showing in black. And the first thing that we need is our R1 and R2. Okay, so I'm going to start with, I've got top of the order over on Zoom is Abby. So Abby, I'm looking for R1 first, is my distance from the axis of rotation to the outermost function. So I need to know, what is this distance here in green? Okay, let me zoom out to get my functions again. So this distance is going to change based on my x value. So it'll change between 6 and 2. So I need a general formula to figure out how much that distance will be. Okay, so I've got two lines. This line in black is y equals -2. And this curve in blue is y equals -x squared plus 4. So what's the distance between the blue line and the black line?
Is it y1 minus y2 over 2?
So y1 minus y2 over 2 would give me, I'm going to say this is y1 for your blue function. And then y2 we'll call your black function down here. So your difference in the y values would actually give us the green line that we want. If you half that, you'd end up somewhere in here. If we subtract these y values, what will we get?
Isn't the difference like y and then like that's a 3. It's 3 and 2, so it's 3 minus -2, the y value.
Okay, we're close to 3 right now. Again, I want a general form though. So my general form is here for y1. You're right though, we are going to be subtracting -2 since that's constant. So this one does not change based on our x value.
Negative x squared plus 4.
Right. I guess just right here in green. -x squared plus 4 minus negative 2. So that's my y value here in blue minus my y value here in black. Gives us the distance between them is r1. Okay. Again, that distance is going to change based on whatever our x value is right now. So here at the start, that distance is 6. And then we're going to keep creating more and more of these cross sections until we get to the end where that distance will be 2. Okay, for any place along the interval from 0 to 2, our value will be our top y value minus our bottom y value, or negative x squared plus 4 minus negative 2. We're going to use that to create a disk that has some depth to it, like this. Okay, so once we've got this large green disk, using our R1, which is our distance from our axis of rotation, to our outermost function, or this function here on the outside, we'll need to cut the inside function. Okay, so this inside function which looks something like this. So we've got this area here, we're trying to spin around our axis of rotation at y equals 2. We still have an inside radius that we need to get as well. So we just got this line here as R1. What would my inner radius be? Andrew?
Inner radius.
Yep. So R2 is my inner radius, which is going to be my distance from the axis of rotation to the inside function.
Is it 2?
Yep, just 2. Okay, so and we're going to use that again to create a disk here. Right, so in this case is just 2 because we've got our y value of 0 minus a constant of negative 2. So after we cut this disk out, we'll have something like this. So we have this large green disk with this hole in the middle that we've cut out of it. and that hole has a constant radius of 2. But the discs are slowly getting bigger and bigger um, as we go from the right to the left, or you could say they're getting smaller and smaller if I go left to right. Okay, any questions on our radii? That's the hard part. Let's simplify this green one over here. This is negative x squared plus 4 plus 2 is negative x squared plus 6 total for R1. Okay, so I'm going to plug that into our formula. Our formula is volume equals pi times the integral from a start point to an end point of R1 squared minus R2 squared dx. So I'm going to jump over to Eric next. I want to plug everything into the formula. So first, what is A and what is B?
Yeah. 1 and 0.
I'm covering some of the drawing, but let me draw on this one then. So I've got the bounds are here in blue y1 of negative x squared plus 4. Here in black at y equals 0. Here in black at x equals 0, and then our intersect here at x equals 2.
Uh, 4 and 0.
Okay, I've got 0 for my start point. Where do we end for our x value?
Set
2,
2.
okay. Then I'll plug in our R1 that we had earlier. And subtract our R2. Dx. Okay, so I've just substituted those in. R1, R1, R2, R2. Okay, over to Niall. Niall, what's going to happen when I expand this?
So it becomes x to the power of 4 negative 12x power of 2 plus 36 negative 4.
Perfect. Okay, and I can subtract that 36 minus 4, and we'll be ready to integrate. Okay, so I'm over to Skype, where I've got Kyle and Nikita. So let me do, I'm going to jump into Nikita first. Nikita, what's going to happen when we integrate?
So it's gonna be pi times x to the 5th over 5 minus 4x cubed.
Okay, you're right. I'm going to write out what you just did there, though. So this is 12x cubed over 3, added 1 to the power divided by the new power. Okay, plus.
Plus 32x.
Okay, and I'm going from 0 to 4. Awesome. Okay, so I'm going to simplify for that last step that you just did, and I'm going to kick this over to Kyle.
Oh, um,
Okay, so Kyle,
I guess we just put it in.
okay, I'm going to plug in upper bound minus lower bound.
2,
So,
plug it in. So 2 plus 1.
okay, when I plug in 0 for all of my lower bounds, then all of this are going to be 0. Okay, so I'm going to try to simplify this a little bit. See, Nikita, can I have you mute the microphone really quick? We've got a little bit of feedback. Thanks.
Brandon.
Yes.
Won't like if the value is x. No, if the value is 0, won't like no matter how
Oh,
much.
so
Um,
Never
is
mind.
it just
I thought of now.
204.8
okay, no problem.
minus?
Um, okay, sorry. I don't think the people on Skype can hear the people on Zoom, but sorry, Kyle. We had a
Yeah, we can't hear the Zoom also.
oh, okay. So I think what I'm going to do is I'm going to try to get a common denominator here, and then we'll leave these in terms of 4s. So we can leave that first term as 4 to the 5th power over 5. What would what would I need to multiply this term by? I need to get a common denominator so I can subtract these.
Oh, so 20 times 4 to the power of 3 over 5.
Okay, I'm going to leave this as 4 to the 4th power, but
Oh, sorry.
and that's okay, times 5. Plus, okay, how about this one?
5.
Okay, we got 5. I'm going to break that 32. If there's any 4s that I can pull out, I'm going to throw that into the 4s. So 4 is 32 is 16 times 2. 16 is 4 squared, so this is 4 cubed. Since 32 is 4 by 4 by 2. Okay, so the reason I've done that is to help us out if we're trying to solve this by hand. So now I can pull out 3 4s from every term. And what will be left?
Four plus 4.
Okay,
4 squared.
4 squared?
4 squared. Plus 10, 4. So 40.
Okay.
Or
Plus, okay, this is going to be 10, since we had 4 cubed, so that'll be pulled out. Okay, and then I've got minus everything from this term.
four squared minus just 4.
Okay, I'll have
Or
1 4 left,
sure.
and then you've got the 5 there as well. Okay, so just to double check, make sure it matches. 4 cubed times 4 squared is 5 4s. Minus
Oh,
I'll have 4 4s here and then 3 4s here as well. Okay. So I'm going to simplify this part on the inside, and then we should be just about done. So we'll have v equals pi times. Okay, what's 4 squared?
4 squared, 16.
Okay, 16 minus 20
So negative 4
plus 10.
plus 10. It's just 6.
Just 6, okay. So I've got 4 cubed times 6. So I need 4 cubed. 4 cubed is 64. So I've got 64 by 6 is 384. Okay. Any questions on anything we did for part 1? I don't know if I can zoom out and get everything in, but let me zoom in and get our setup at least. Any questions on our setup for part 1?
No.
All right, let's do one more. And that was actually everybody. I'm going to skip Abby for the first one since she did R1 last time. And we'll start with Andrew for the next one. Okay, same idea. So we're going to take this blue area and we're going to spin about this black line. Where our function showing here, this is two x minus 3. I might actually do this in another color too. I'm going to do this in another color, I think. So let's draw over this and try to make it red. Okay. Color wheels. Okay, that'll work. So we've got y equals 2x minus 3 here in red. And here in blue. Y equals x squared minus 3. In black, our axis is y equals 1. Okay, so I'm over to Andrew. Andrew, what would my R1 be? So that's my distance from the axis to the outermost function. So it's going to change based on whatever our x value is, from x equals 0 to x equals 2. So I'm going to pick somewhere in the middle. My line would look like this. Distance from the axis to the outermost function. Okay, so what is this distance?
One minus x minus 3.
X squared minus 3, okay.
Yeah, x squared minus 3.
Perfect. R1 is here. Okay, and then I need an R2 as well, which I'm going to draw in yellow this time. Next in the order is Eric. R2 is the distance from the axis of rotation to the innermost function. What should R2 be?
Minus 2x minus 1.
Okay, that's perfect. Okay, and what we'll do once we draw this out is we're going to use those radii to spin this about the axis of rotation. So that'll end up looking like this. So between -2 and 3, so here. So we are creating a disk. Again, it has an infinitely small depth. And it has our radius there in green. Which we're using to create our larger disk. Okay, and I'm going to use my radius here in yellow to cut out another disk from it. So that radius was roughly 2 units, so somewhere around here-ish. Okay, exaggerating my radius, but we're cutting out this orange disk from this green disk. Any questions on what we're doing? Okay. So with that, keep showing my R1 here. One more line. There we go. Okay. So I'm going to combine these and we'll create our volume. I'm going to jump back up to Abby. So I need to plug into our general form, pi times the integral from a to b of r1 squared minus r2 squared. What is a and what is b?
A is
Okay, those actually weren't given, so draw our picture one more time. I've got something that looks like this, roughly. For our functions at 2x minus 3 and x squared minus 3. Okay, since they weren't given for these x values, what could we do to figure out when these two lines cross?
so x set y to 0.
Close. I need them.
X to
Okay, when x equals 0, they do touch, since y1 will equal y2, but that's actually what we're going to do. I'm going to set y1 equal to y2, and then we'll solve for x. So we'll prove it really quick. This is 2x minus 3 equals x squared minus 3. We should get two answers here. One of them you just gave me. When x is 0, these two will equal each other. So let's solve for x. I'm going to add... okay, go for it.
like so move 3 when we move x we move negative 3 to each side, they will get cancelled, so x squared equals 2x.
Okay. Okay, so that gives us two possible answers when I factor out. This will be true whenever x is what?
2.
Okay, x is 2 or x equals 0 are my intersections. Okay, so that's a is my first one, x equals 0. B is 2 then. Okay, so we're ready to plug in. I've got R1, R2, A, and B, which is everything we need for our formula. Um, 1 minus x squared minus 3. So the 1 minus negative 3 will become 4, so that's 4 minus x squared. And then 1 minus 2x minus 3 is 4 minus 2x. Okay, next on the order, I've got Let's see, Niall, I had you do expansions last time, so I'm going to skip you and come back. Nikita, what will happen when I expand these?
Can you say it again?
Yep, what happens when I expand these?
Oh, do you want me to? Oh, okay, okay. So it's gonna be x to the fourth minus 8x squared plus 16 minus 4x squared um
Oh,
with 2x times. Wait, shouldn't be 16x since we multiply 2x by 2 and then also by 4.
okay, so that's your next
Okay.
term. Minus 16x
And plus 16.
plus 16. Perfect. Okay. And then I just need to combine like terms, and we should be ready to pass this on to integrate. Okay, so this is x to the fourth. I've got negative 8x squared minus 4x squared is negative 12x squared plus 16x. And then 16 minus 16 is 0. Okay, I'm going to jump over to Niall next for our integrals.
So it becomes x power 5 over 5 negative 4x cubed.
Okay, you're right, but I'm going to write that out. Plus.
And 8x squared.
Okay, again, you're right. I'm just going to write that out. Okay. 0 to 2. Which you told us was this. It's the fifth over 5 minus 4x cubed plus 8x squared, and then I've got bounds. All right. And I had Kyle plug in last time too. So I'm going to skip Kyle. Let's jump back to Andrew then. So I want to plug in my upper bound and subtract my lower bound.
Okay, so 2 to the 5th power over 5 minus 4 times 2 to the 3rd power.
Okay.
The easier way.
If I get a common denominator, what's going to happen?
Then it will be 20 times 2 to the 3rd power plus 40 times 2 to the 2nd power 2 squared over 5.
Okay, so what I'm going to do just to show you what's happening here is I'm going to break apart as many 2's as I can and put them over to the other term. So this is 4 times 2 cubed. That 4 is 2 squared. 2 squared times 2 cubed is 2 to the 5th power. So this is minus 5 times 2 to the 5th power. This was 8, which is 2 to the 3rd power, times 2 to the 2nd power is 2 to the 5th power. So this is 5 times 2 to the 5th power as well. Okay, any questions on what I did there? I'm just breaking apart my 2's. Okay. So, Andrew, let's finish this off. I've got a common denominator, so we can add and subtract straight across. What's going to happen here?
So the 5
Okay.
Answer me. 2 to the 5th power over 5 times pi.
Perfect. 2 to the 5th power over 5 times pi. What is 2 to the 5th power?
32.
32 pi over 5 for a final answer. Okay. Any questions on what we did here? Okay. Any questions on our setup? All right. I've got time for maybe one more. So last one. And I'm going to start with Kyle this time because I skipped you for the end of the last one. So here I've got an area bounded by y equals 2 cosecant, y equals cosecant, x equals pi fourths, and x equals 5 pi 6. I'm spinning around the axis y equals 0.
So is this similar to the homework we did recently? So it'll be y is equal to 2 cosecant x minus cosecant x. 2 cosecant squared minus cosecant squared.
I don't know if I can change the colors here, but okay. So I think I'm going to try really quick. Man. Alright, as good as I'm going to get. Alright. So I need R1 first.
R1 is 2 cosecant.
Okay, perfect. So R1 is 2 cosecant x. I'm going to jump over to Abby. Abby, what is R2?
R2 is 1.
Right now, yes, but this needs to be true for all x values, so that won't be true over here on the left or here on the right.
So it's just CSDX.
Yes. So this is really the distance between our innermost function, which is in red, and our axis of rotation here in black. But since our axis of rotation in black is 0, this is CSCX minus 0, just like our first one was 2 cosecant x minus 0, really. Okay, so what we just did was this. I'm going to take this green radius and spin that around our axis of rotation to make a two-dimensional disk here in green. And then we'll give that two-dimensional disk some depth. So this is our 2D cross-section. Once I add some depth to it, it'll become an infinitely small three-dimensional disk shape. With this infinitely small depth that is my change in x. Okay, then we used our yellow function for the radius to cut out a smaller disk from the inside of this. So this disk here in orange to make it hollow. Okay, any questions that are set up for R1 or R2? Again, that's the hard part. And draw our axis here. Okay. So then I've got an A and a B, a start point and an end point. Andrew, what's our start point and what's our end point?
Our start point is pi over 4, and our end point is 5 pi over 6.
Perfect. Okay, so we just need to plug this into our formula and get ourselves ready to integrate. Okay, so I've got general formula one more time. We're over to Eric next. I'm going to plug this in. Pi times the integral from pi fourths to 5 pi 6 of 2 cosecant x squared minus cosecant x squared dx. What will happen when I square this and subtract?
Or secant x squared minus x squared.
Okay, so this would be 4 cosecant squared minus cosecant squared. So what do I have left?
3
Perfect.
secant x.
So we'll be left with 3 cosecant squared. Pi fourths to 5 pi 6 of 3 cosecant squared x dx. Okay, over to Niall. Niall, I want to work backwards with my integral. So what function would I derive in order to get cosecant squared?
Negative cotangent.
Perfect. So when I integrate 3 cosecant squared, what will I end up with?
So, cotangent x.
Perfect. From pi fourths to 5 pi 6. Okay, so that brings us to, we've got unit circle values for plugging in our upper bound and lower bound. We've got 2 unit circle values we'll need to deal with. Our first at 5 pi over 6, which would look like this. That has a long side here and a short side here. So I might color code. Our short side over here. Short sides are always 1/2. And our long side here. Long sides are always root 3 over 2, but since we went left here for our x value, this is negative. Then this is a cotangent. Cotangent is what happens when I flip tangent. Tangent is y over x, which means the cotangent must be x over y. Okay, who am I on? I'm on Nikita. Nikita, with all of this, what will the cotangent at 5 pi 6 be?
Can you read my connection was bad?
What is the cotangent at 5 pi over 6?
Wait, 5 power 6 it. I'm not sure.
Okay, can you see the video or not?
Which one?
Okay, so right now we're looking at our unit circle value here. We are currently at 5 pi 6.
Oh, okay.
Our cotangent is the x value divided by the y value. So we got our x value
Oh,
here
okay, okay.
and y value. Okay,
Okay, so that's gonna be just negative square root of 3.
perfect. Okay, that was negative root 3 over 2 divided by our y value of 1/2. If I divide these, I've got a negative 1/2 here, which will cancel with my 1/2 on bottom to give me negative 1 times root 3. Okay, so that's my upper bound. And then, Kyle, I'm going to have you do our lower bound. Our lower bound is at pi fourths, which would be here. Redraw really quick. Pi fourths. Okay, at an odd value times pi over 4, our side lengths are equal. So that means if I keep this in the same color code, both our x value and our y value are equal. Which would give us square root 2 over 2 for both of our sides. Okay, so if the cotangent, again, is x over y, then what is the cotangent at pi over 4?
Pi over 4. Oh. Oh wait, is it just 1?
Yes. So that's root 2 over 2 divided by root 2 over 2. Anytime we divide the same number by the same number, we'll get 1. Okay, so that's all our unit circle stuff. I'm going to block this off from the rest of our problem. And we'll finish off with our upper bound minus lower bound. So this is our volume is equal to pi times -3 times the cotangent at 5 pi 6, or negative root 3, minus -3 times the cotangent at pi 4ths, which is 1. I guess I'm going to give this to you for your notes for your homework, so I'm going to go ahead and write that step out before I just plug in. This is -3 times the cotangent at 5 pi 6 minus -3 cotangent of pi over 4. Gives us -3 times negative root 3 minus -3 times 1, or -3 times negative root 3 is positive 3 root 3 times pi is 3 pi square root 3. And then I've got -3 is positive 3 times pi. Any questions on what we did here? Rewrite my 3's here. Not changing anything, just want you guys to be able to read these for notes. Add a line here so we know those are 2 different unit circle values. All right. So I've got homework that I'll post to the WeChat right now.
The homework is due on Tuesday?
Homework will be due on Tuesdays. There's 10 problems, kind of like the first one that we did with volume by cross sections. And that'll be it for today. So I hope you guys.
9 a.m.
Midnight. Okay. So I hope you guys have a good weekend. And if you guys have questions, please hit me up through WeChat.
Thank you.
Thank you.
Bye.
Bye.